Hello, beautiful people. Thank you very much for joining me today on this educational journey of mine. Today, we are going to talk about interfaces in computer science in general and in golang specifically. So, let us dive straight in. Interfaces are a fundamental concept in computer science and software engineering. In essence, an interface is a contract between different components of a system that defines how they can interact with one another. In a broader sense, interfaces are a key part of how computer systems and software are designed and organized. As a computer science student, you are likely to encounter interfaces in a number of different contexts. Here are some common examples. For example, there are user interfaces. These are the interfaces that allow humans to interact with a computer system or application. Examples include graphical user interfaces, also known as GUIs, command line interfaces, also known as CLIs, and web interfaces. The second common example of interfaces in computer science are so-called APIs or application programming interfaces. These are the interfaces that allow different software applications to communicate with each other. APIs define the protocols, data structures, and functions that one application can use to interact with another. The third example of the common use of the interfaces is the following. Object-oriented programming interfaces. In OOP, an interface is a set of methods that a class must implement in order to be considered a subtype of the interface. This allows for polymorphism and other powerful programming concepts. Alright guys, we're coming to the final example. That's definitely not everything there is that can be told about them interfaces, but we're trying to keep it brief today. So the fourth example of the common use of the interfaces sounds like this. Network interfaces. These are physical or logical connections between different network devices. They define the protocols and data formats used to send and receive data over the network. Overall, interfaces are a key part of modern computing, and understanding how to design, implement, and use them effectively is an important skill for any computer science student. Thank you very much for listening to the first part of this small thing where we talk about interfaces. I remind you, we've talked about interfaces in general, about what people understand when bringing up interfaces in the context of computer science. What are the more specific situations, or rather concepts of communication where you would have to use this term to describe what's actually going on. So let us move on to a more specific thingy. Let's talk about the interfaces in Golang in reference to the general notion of interfaces. So, in Go programming language, an interface is a collection of method signatures that define the behavior of an object. It is similar to the general notion of interface in the way that it defines a contract that a type must satisfy to be considered compatible with the interface. In Go, interfaces are defined using the interface keyword, followed by a set of method signatures. Here's an example. So as you know, Go is a statically typed language, which poses a certain problem, where a function can only accept arguments of a certain type. But what if we need a function that would accept arguments of different types? So let's come up with a simple example. Let's say we have many custom types that represent different shapes. And let's say we have two of those custom structs. One of them would be rectangle, another one would be square. Both of them have similar fields, width and height. And then we have a function called shapeInfo. And we really want this function to receive an argument of both rectangle type and square type. But we cannot really do this literally because Go is a strictly typed language and a variable cannot be of two types simultaneously. So that's when interfaces are really going to help us. So let's define an interface using the keyword interface and call it shape. That would define two methods, area and perimeter. Both of these functions receive no arguments and return a float. Then we have both of our structs of our custom types, rectangle and square, implement these methods, area and perimeter. Well, with the most obvious logic inside of those functions, right? Alright, and now when we have those structs, those custom types comply to our interface, we can actually complete the shapeInfo function by setting its argument to be of interface type shape that already has two custom types, rectangle and square, complying to it. This example shows how interfaces can be used to provide a flexible and extensible design in Go, enabling polymorphism and reducing coupling between different parts of a program. Alright, thank you very much for listening to this little piece. It's going to help me immensely to get myself ready for the upcoming interview. Hopefully it will educate you a bit or remind you of certain things, and who knows, maybe even entertain. Bye bye, thank you.